Okay, let's look at practice exam 3, problem number 1. All right. So it says that the boat is being pulled toward the dock. So you have a boat. So let's draw a picture. All right. And toward the dock. So let's say you have a dock right there. Right. And it's pulled toward the dock, and let's say rope is being pulled by a winch located 5 feet above the dock. So winch is going to be up here, right? So this is going to be 5 feet right there, and the rope is probably like that, right? That doesn't look good. Let me like that, and here's the water, right? All right, then it says that, let's see, for above the dock and at the rate of 4 feet per second. So rope is pulled in. So this is going to be 4 feet per second, right? And it's asking how fast is the boat approaching. So we want to know how fast that this is going this way, right? So this is going to be how fast, feet per second. When it is 12 feet from the dock. So from here to there is 12 feet. So maybe I'll write that 12 feet. All right. So let's do that. All right. So first thing we need to do is we have to give variables. All right. The quantity that are changing. All right. So let's say length of the rope is changing. So I'm going to give a variable, say R, since it's a rope. All right. The distance between the boat and the dock is changing. So I'll probably give length here. Actually, maybe I'll put, so this is the 12. So from here to there, right? And this is, I'm going to call this guy X, right? Then you can see that you can kind of visualize a right triangle right here. So I'm going to pull that out to make it clearer, right? So you have that, and you have this, and that, right? So visualize a right triangle, which looks kind of like this, right? So this corresponds to the height of the winch, so it's going to be 5 feet here, right? We decided to call the length of the rope R, and the distance between the boat and the dock is going to be X, like that. All right, so by Pythagorean theorem, so I'm going to use a Pythagorean theorem. All right, we can come up with the equation. All right, so x squared plus 5 squared is equal to the r squared. So it's going to be x squared plus 5 squared is equal to r squared, right? And there's some given values, so I'm going to write down what's given. So here's a given. All right, so given value. All right, so we know that x is going to be 12 at that moment. So x equals 12. Right? Then since the rope is pulled in at the rate of 4 feet per second, so we know that the rate of change of the length of the rope with respect to time t is equal to, right? So it's going to be shrinking at the rate of 4 feet per second, so it's -4, right? And we can actually find the length of the rope using the Pythagorean theorem. So length of the rope R is going to be equal to square root of, right? So R squared is x squared plus 5 squared. So it's going to be, let's see, x is 12, so it's a 12 squared. plus 5 squared at that moment. All right, so you have 144 plus 25. So it's going to be 169, which is, I think it's square root, it's 13, right? So it's 13. All right, so we got all these values, and all we are looking for is how fast is the x is changing, because that's equivalent of the speed of the boat. So we are looking for dx over dt. All right, so that's what we're looking for. All right, so we have to create that dx over dt from this Pythagorean theorem here. So what we're going to do is we're going to take the derivative. So we're going to take the derivative with respect to t. Right? So derivative of x squared would be 2x dx over dt. Right? And derivative of 5 squared, since it's a constant, it's 0. So I'm not going to write anything down there. So is equal to derivative of r squared is 2r dr over dt. Right? And let's simplify. So we can just, we are looking for dx over dt. So I'm going to try to isolate this guy. So we can do that by simply divide the whole the equation through by 2x. Right? So you will get dx over dt is isolated. Right? So you have a 2r dr over dt divided by 2x. Right? So you have 2 on top and 2 on the bottom. They cancel out. So you have r on top over x dr over dt. Right? Then plug in what's given. So r is at that moment is 13. So put 13 here. Right? X is 12 at that moment. Right? And dr over dt is -4. Right? So you can cancel 4 and a 12. So 3 is left over. So therefore, you will get the negative. So that's negative sign here. So you have 13 over 3. All right. So the answer is how fast is the boat approaching the dock? So how fast? So you can just ignore the negative sign. It tells you that it's the distance is shrinking. Right. So therefore, the speed of the boat is 13 over 3 feet per second. All right, that's it. I hope that this was clear.